Alright, hello. In this video, we are going to be reviewing for quiz 7.1 to 7.3. As always, I'm going to ask that you do a lot of these questions. These should be review, so try them first before pausing to see the answers. Class, for this you'll need a piece of paper and a calculator definitely to do the exponential. So the first one is just basic about what is an exponential. I don't actually have Twitter, but just a made up example. I have 3 followers, I tell some funny jokes, and I gain 2 followers per week. That sounds about right. Mr. Paris, very popular on Twitter, 100 followers, and he's much, much funnier than me. So he's going to increase by 10% each week. Which one of those would be exponential, and then explain. Pause the video and figure it out. All right, so letter A is actually a linear one, so it's not exponential. Okay, and if you think about it, I like to think about it in chart form. So we have like the weeks, and we have like the number of followers. Okay, so like in the beginning, after 0 weeks, I have 3 followers, and then after 1 week, I gain 2, and then again another 2, blah, 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 right? So it's just going up in a linear pattern, going up by 2 each time. Okay, versus, so again, graphically, right, that's just going to be a straight line graph like that. An exponential, though, like here, Paris doesn't go up by the same amount, he goes up by a percentage. So if we were to look at his weeks and followers, right? Week 0, he has 100 followers, but then he gains 10%. So 10% of 100 is 10 more followers. Okay, but now when he goes on to the next week, he's doing 10% of 110. So 10% of 110, if you use a calculator there, that gets you 11 additional followers. So now he's going to be at 121. Okay, and then the next time he's going to have 10% of 121, which I think it's like 12.1, so maybe we just round it to like 12 new followers. So it'll be something like 133. Okay, so you can see Paris is not going up in a consistent amount, right? His is going to start slowly, grow slowly in the beginning, but eventually it's going to go higher and higher because 10% of a bigger number is a bigger value. So over time, that 10% increase is more significant, right? So his would be the example of the exponential. Right, if you wanted the formula there, by the way, since a lot of that is part of this test, you would just say like 100 followers times 110% to however many weeks have gone by. So his followers are equal to 100 times 110% to the week's power. So if I wanted to do the 20th week, how many followers then? You could just put in 20 and crunch away on your calculator. Okay, so we're going to start with some exponential ones. I'll get the formulas. I forgot them there. There's 2 different formulas, one for continuous interest and one for the yearly interest, right? And on these ones, it doesn't say continuous on them, but I would think these would be continuous because Bitcoin's value changes continuously, so continuous. So I didn't put it on there, but assume that's continuous interest, and I'll get the 2 formulas. Okay, so I added the formulas here. You got to figure out which one is a continuous. We already talked about this would be continuous interest, but see if you can figure it out and then use the formulas to get your answer. Okay, so continuous formula is this one, PERT, where P is the principal, E is this number, like 2.71 or whatever, R is the rate, and T is the time. So if I want to know the amount principal after 3 years, all right, and don't forget, that's just the function notation saying I'm input, I guess I should say A of 3. The amount after 3 years is the principal, 33,000 times E to the rate as a decimal. So I'm going to move it over twice. So it's 0.153 and then times 3 years, right? And so if you crunch all that, that'll get you the amount after 3 years. Okay, and just to show you how to enter it on the calculator, and do the 33,000, and then in parentheses, I'm going to do e to the x. So there's an e to the x key right here. And then I might do another parentheses just to be safe, but I'm going to enter my rate as a decimal times the years, which was 3. Close that down, move it over, close it again. I suppose this other parentheses here is a little bit excessive, but I think that's the right setup. I'm gonna check to make sure. Yep, that looks right. So now I'm just gonna hit enter. Okay, and I'm at $52,222.19. So quite a bit after just 3 years. That's actually a really good deal. Right, that's quite a bit. In just 3 years, it went up, not quite double, but getting close to it. Okay, and so some people do think Bitcoin is going to go to 100,000. I got a friend who's convinced that this is true. So to do this, basically, we're just going to enter it with like Y and X on the calculator. So it's going to be sort of the same setup, right? 33,000, and then to the same percentage, so 15.3%. But now I'm just going to times X because we don't know how many years. So we want to find the amount Y after X years. So sorry, that's supposed to be a comma there, and that looks terrible. But basically, I'm going to use the Y equals screen and then figure out when it reaches 100,000. Okay, so instead of entering it here, I'm going to go Y equals, clear out whatever I've got, 33,000, do my E to the X key, and then I'm going to put here the 0.153 to the X year, close the parenthesis. Okay, and then instead of graphing it, I'm going to look at the table. So I'm going to go second and the graph key. And now I can see the amount after all the different years. So it looks like 100,000, it'll reach that somewhere like 7.5 years. But maybe I'll just say the year that it'll finally be over 100,000 is 8 years. So you could say about 7.5, or I'm just going to put down 8 years is when it'll finally reach over 100,000. So not very long, actually. That's pretty good. It's a pretty good return on your investment. Sorry, I lost my screen there. So we'll just answer this as 8 years. If you put 7.5, that worked too. Oh man, why I'm struggling so much? I don't know. Okay. Want to try at least one more of these exponentials. So this is a pretty famous math question. So you have a choice, right? You're going to get a bunch of money, right? And you have a choice of either $10,000 per day for every day in January. There's 31 days in January. Or I'll give you a penny on January 1st, 2 pennies on the 2nd, 4 pennies on the 3rd, and I'll keep doubling every day all the way to January 31st. So which one is a better deal, right? Which one would you rather have? Pause the video and see if you can make some sense of this. Okay, so scenario A is pretty straightforward. You just take 10,000 times 31 days, right? And that's going to be 31 10,000s. So I think that's something like that, if I did that math right. So not bad, $310,000. Okay, so the other one is an exponential. So basically the amount after each day, I should use day instead of t here, but basically I have 1 cent to start with, and I'm going to take it times 2 because it doubles every day. Right, so that's sort of our setup, is start with 1 cent, multiply by 2 so many days. Okay, so a good way to look at this, because I have to add all these values together, right? I'd have to add 1 cent to 2 cent to 4 cent, right? So that gets a little bit of a pain, but let's actually just use our calculator again. So I'm going to go back into y equals, and I'm going to put in here, let's see, so I'm going to put 1 cent times 2, and then raise that to the x power. Okay, and then I'm going to look at the table again. Right, so you can see that on day 1 we have 1 cent, actually day 0. So maybe this is off, these days are off by 1, I guess. So this is like day 1. So anyways, we can start to look, it's going up pretty fast. I'm still not making much here. But you can see this is kind of how exponentials work. This doubling effect is like super powerful. So it starts to get big. Takes a little bit of time, but once it gets big, then it's just booming. Right, so if you look, oops, it's going to scientific notation there. But I think on day 30, which would technically be the 31st day because we started on 0, but we're already getting, geez, I think that's like $10 million on the 31st. This is like 5 million, I think. Yeah, this is 1 million, 2 million, 5 million, and then this is like 10 million, even though that's scientific notation. So already on the 10th day, or sorry, on the last day, the 31st day by itself, So just on Jan 31st, we are getting by itself about 10 million. Okay, so clearly that's going to be the better option because we're add all the previous days to that too. So I think this whole option, if you did it, it probably comes out to be right around $20 million, right? So if you added all the days together, so that's much better option. Okay, so let's do a few log questions too. So you just got to think about what does that word log mean, and then find X in these different situations. Pause the video, give it a shot. Okay, so log means like find me the exponent. So letter A is probably the most straightforward one, where this bottom number is the base. Okay, and the 8 is the value we want to get. And since log means find exponent, X is going to represent the exponent we need to get a value of 8. So it's going to be 2 to what power, or sort of 2 to X, will give us 8, and that answer there is 3. So in this case, our exponent X is 3. Oftentimes they won't even put this here. They'll just say evaluate it, and then you have to say that it's 3. But I thought I'd put an X there just to make it clear what we were finding. Okay, and that's how kind of all we do all of these. So this says a base of X and a power of 2. This is my exponent. And I want to get a value of 25. So what we need there for X is just 5. Right? 5 to the power of 2 is 25. Right? And so essentially I'm switching forms, right? So this one I'm saying my base is 2, my exponent is 5, and my value is X. So base of 2 exponent 5 equals X. So that means X would be, I think that's 32 if you do 2 to the 5th. Hopefully that's right. Yeah, I'm going to say that's right, 32. Okay, so that switching forms becomes important, and that's actually the last thing I want to review here is pause the video here and see if you can switch. We have the exponential form and the log form, right? So practice switching back and forth between the two of them. Pause the video. Okay, so when I do this, I always do the base and exponent first. So I'm going to do log, and then my base here is the 1/3, and my exponent is the -2. So in log, the little base goes down here. And since log means find exponent, I put it over here. And then my value goes there. All right, second one, I got exponent of 3 and base of 1/4. So again, I always start there. So I'm going to do log with my base of 1/4 equals my exponent of 3. And then my value is 1/64. Going the other way, again, I always start with the base. The base is a little number down there, so that's my base. And log means find exponent, so my exponent is 2.5. We're going to do base of 4, exponent of 2.5, and that should equal 32, right? And you can kind of check this, right? Like on your calculator or something, or even just mentally. Like 4 squared is 16, so 4 to the 2.5, that could be 32. That seems reasonable. So, yeah, that's it. We switched the forms. All right, that's it for your review. Thanks for watching.